Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of parallelograms where I will discuss about the proof of the properties of parallelograms that I have discussed in the previous video part 1, and will also solve some problems based on the properties of parallelograms. If you have not watched the part 1 video where I discussed about the parallelograms in general, the geometric structure and properties of parallelograms and their properties, I highly suggest that you please watch the part 1 video also. So this video is part of the playlist CBSE Maths 8 for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 2 video on the chapter of parallelograms. Okay, so I have my rough notes prepared on the right hand side. First, I will do the proof of all the properties of parallelograms. I discussed about 5 properties in the part 1 video. I will do the proof of these properties, and then I will solve. There are 5 problems. These are good problems purely based on the properties of parallelograms. So this video might be a little long, so please bear with me. Okay. So the first property is that the opposite pair of sides are equal in a parallelogram. So ABCD is a parallelogram, and we need to prove that the opposite pair of sides are equal. That is, we have to prove that AD is equal to BC, and we have to prove AB is equal to DC. Now all the proofs will be heavily based on the concept of congruence of triangles. So we will using a diagonal, we will create 2 triangles. As you know that a diagonal in a parallelogram creates 2 triangles. Even though those 2 triangles are congruent, but that itself is another property that we will prove later on. But using the congruence of triangles and the basic concepts of parallel lines and transcendental, we will that is the alternating interior angles are equal, and the sum of adjacent angles on the same side of a transcendental is equal to 180 degree. All these concepts will be used. Okay, we have to prove this. How do we prove this? Okay, let's create the diagonal AC. So this is the diagonal AC, and let's work on. So we have the triangle. Let's see. We have the triangle ABC, ADC, and triangle ABC. We will try to prove that these 2 triangles are congruent, and based on when it is proved that triangle ADC is congruent to triangle ABC, it will be we can easily say that AD will be equals to BC and AB equals to DC based on the congruence property of the triangles. Okay. Now, how do we prove that triangle ADC and triangle ABC are congruent? Okay. So in triangle ADC and triangle ABC, we see that AC is equal to AC, that is the common side. It is the common side. Now remember the properties, the conditions of congruence of triangles. We have SAS, that is side angle side. We have ASA, that is angle side angle. We have RSA, and I guess there is one more, I do not remember. Anyway, let's see. Oh, another one is side SSS, I guess. Okay, the RSA is the right angle triangle, where the 2 triangles are congruent if both are right angle triangles and the hypotenuse is same and probably one arm is same. Okay. Okay, so see in this triangle, a triangle ADC and ABC, we see that AC is the common angle. Okay, so this is the common, not angle, common side, and also we see that this angle, that angle ACD is equal to angle CAB. CAB. This is because AB is parallel to DC. So this angle is equal to this angle. Since AB is parallel to DC, and you can consider BC is the transcendental, that is intersecting the parallel lines AB, parallel segments AB and DC at two different points B and C. AB and DC are the parallel lines, and AC is the transcendental, that is the diagonal AC is intersecting the parallel sides, opposite parallel sides AB and DC at two distinct points A and C. So we have alternating interior angles. Angle ACD and an angle CAB are alternating interior angles, so they must be equal. Okay, so we have one side equal and one angle equal. Okay, also what else? Okay, so again we know that AD is parallel to BC, that is they are pair of opposite sides or pair of opposite sides, so they are parallel. Since this is a parallelogram, so we must have this angle, so we must have angle ACB, we must have angle CAD is equal to angle ACB, since AD is parallel to BC. AD is parallel to BC. Again, AC is acting as the diagonal. AC is acting as the transcendental. So we must have this angle should be equal to this angle. Okay, so we have two angles and two angles equal, one side equal. So we must have the congruence of this ASA. Congruence must happen. Let's see. Now remember, ASA congruence, in ASA congruence it is angle side angle, that is two angles and the side is the side included between the two angles. So let's see. So we can see that in the triangle ADC, angle DAC and angle ACD are equal to the corresponding other angles of the triangle ABC, and also the common side AC is equal. So definitely we are having, so this implies we can say we are having ASA triangle congruency, ASA triangle congruency satisfied. So this implies that triangle ADC is congruent to triangle ABC. So since these two triangles are congruent, all the corresponding sides and angle must be equal. So now since AC is the common side and AC is the common side, now angle, so two angles are already equal. We have already established that two angles of triangle ADC is equal to two other angles, two corresponding angles of triangle ABC. So we must have the remaining angle in both the triangles should be equal, that is angle ADC should be equal to angle CBA, and also the sides we have to properly from the congruency property, we have to, from the congruency of the two triangles, we have to properly establish the correspondence between the sides. Okay. Now, mm, okay, so we see that angle D is equal to angle B. This was this we got from the fact that triangle ADC and angle ABC are congruent. Now, okay, so we can say that the side included, consider the triangle ADC, the side included between the angle side included uh, let me give some name. It will be easier to refer the angles. So let's say this is xt, this is x, this is y. Even though x and y are equal, I am just giving different names. And let's say this be p, this be q. Let's say this be r and this be s. So we see that I hope you are aware of how when you have established a congruency between two triangles, then what are the corresponding angles and what are the corresponding sides. Since angle R is equal to, now what is, so we have R is equal to S, that is R angle of triangle ADC is equal to S angle of triangle ACB. Okay, and we also have x is equal to y, that is x angle of triangle ADC is equal to y angle of triangle ABC. Now side included, this will imply when we have this, based on the fact that the two triangles are congruent, this should imply side included between angles R and S should be equal to side included between angles S and Y. Now R and X are angles of the triangle ADC and S and Y are angles of the other angle ABC. So what is the side included between the angles R and X? That is the side AD. So we must have AD equal to, and what is the side included between the angles Y and S? That is this BC. So we got AD is equal to BC. Similarly, so we got AD and BC are opposite pair of sides and they are equal. So one pair of opposite sides is proved to be equal. We yet need to prove that AB is equal to DC. Now to prove AB equals to DC, again see that what are the angles inside which the side AB is included. Or DC is included. So we have again X is equal to Y, and we have Q is equal to P. We have already established that X is equal to Y and Q is equal to angle X is equal to angle Y and angle Q is equal to angle P based on the labeling that I did on the diagram. Okay, so this will imply that side included between angles X and Q should be equal to equal to, side equal to means that their length should be equal to side included between the angles y and p. So this implies what is the side included between the angles x and q, that is DC, and what is the side included between the angles y and p, that is AB, that is AB. So we have proved, and AB and DC are pair of opposite sides. So we have proved that both the pair of opposite sides are equal. This was the property that opposite pair of sides are equal. Okay, let's see the next property. Opposite pair of angles are equal. This proof is also will be similar. We have to using the diagonal AC. The proof will be very similar. So let me not for proving that opposite pair of angles are equal, I eventually will have to make the diagonal AC and prove that the triangles ADC and ABC are congruent, which I have already done for proving the opposite pair of sides are equal. So as we know that using the fact that the triangle is the diagonal AC is dividing the parallelogram into two triangles ADC and ABC which are congruent, I am using that fact, and from there I will prove that the opposite pair of angles are also equal. So let me draw the diagonal. So this is the diagonal. So we know that we already know that triangle ADC is congruent to triangle ABC. Okay. We need to prove that. What we need to prove is angle A is equal to angle C and angle D is equal to angle B. This is what we have to prove. Okay. Now, since the triangle ADC is congruent to triangle ABC, by the way, it is very important that while mentioning the congruence relation between two triangles, you name the triangles properly. I did not notice that. So I said that triangle ADC is congruent to triangle ABC. If this is so, then AD must be equal to AB. No, I did it wrong. So the congruency relation should be, this is wrong. This is very wrong. This is super important. So I should name the relation property, the relation of the congruence relation of two triangles properly. That is, I should name the triangles properly. Okay, so we know that if we consider the triangle ADC, let's say triangle ADC. Now, based on this triangle ADC, I have to properly name the other triangle ABC. Now, I know that AD is equal to BC. So, definitely I can say this will be B, C, and this I can say A. So, the idea is that if triangle ADC is congruent to triangle BCA, then if you take from the left hand side triangle, if you take two letters at a time, that is two vertices at a time, then A and D, it is making the side AD. So AD must be equal to the corresponding side of the other triangle, that is BC. Similarly, DC must be equal to CA. No, sorry, what I am doing. DC must be equal to, no. How do we properly give the congruence relation? It is very important. So we have AC is the common side. Okay, AC is the common side. AD is equal to BC. AD is equal to BC. Okay. Now, if I do this way, CBA. I think this is correct. So AD is equal to CB and DC is equal to AB or BA. Okay, and CA is equal to AC, that is the common side. Okay, this is the correct congruence relation between the triangles ADC and CBA. It is very, very important. You should always, while establishing a congruence relation between two triangles, you should name the triangles properly. That the naming of the triangles will give when you mention the congruence relation between two triangles, from there only it is evident what is the congruence, what are the correspondence between the angles and the sides. Okay, ADC and CBA, ADC and so this will be CBA. Okay, so this is the congruence relation between the two triangles we know. Okay, so from here we can say that we already know that this angle is equal to this angle, and we also know that this angle is equal to this angle. Well, okay, so this proves that opposite pair of angles are equal. I think the congruence, the fact that the triangle ADC and CBA are congruent, this will not be required. It is enough that the opposite sides are parallel. From the fact that the opposite pair of sides are parallel, from that fact only we can establish that the opposite pair of angles are also equal. Okay, so we have this. So let's not use this fact. It will be not required. Okay, so we know that since we know that AB is parallel to DC, implies that angle, let's give a name, let's say let's this be X, this be Y, and this be A, and this be B. So we must have AB is parallel to DC, DC, and AC is the transcendental. I hope this is the term, transcendental. Then transcendental. That is, if a line intersects two parallel lines at two distinct points, then we have opposite interior angles, and we have alternating angles, opposite alternating angles, and we have interior angles on the same side, and they are equal. That is, opposite alternating interior angles are equal, and the sum of the adjacent interior angles on the same side of the transcendental, their sum is equal to 180 degree. Okay, so if AB is parallel to DC and AC is the transcendental, we must have angle X is equal to Y, angle Y. Also, we know that AD is parallel to BC. AD is parallel to BC, and AC is the transcendental, and AC is the transcendental. I hope this is the word. I am not sure. AC is the transcendental. This will imply that A is equal to B, because they are alternating interior angles. So X and Y are alternating interior angles. So also A and B are alternating interior angles. So if let's say this is result 1, that is X is equal to Y, angle X is equal to angle Y, and let's say this be result 2, that is angle A is equal to angle A is equal to angle B. So adding 1 and 2, if we add the two results 1 and 2, when we add two equations, 1 and 2 are two equations. When we add two equations, we get another equation, that is where the LHS is the sum of the LHS of all the equations, and the RHS is the sum of the RHS of all the equations. So we get x plus a is equal to y plus b. Now what is x plus a? X plus a is angle A, and what is y plus b? Y plus b is c. So we proved that angle A is equal to angle C, and angle A and angle C are opposite pair of angles. Okay. Similarly, so angle A is equal to angle C. Okay. How do we prove angle B is equal to angle D? I think I have to prove angle D is equal to angle B, I have to use the other diagonal, that is DB. Okay. Now we know that AD is parallel to BC. AD is parallel to BC, we know. AD is parallel to BC. Okay, now we have to name few more angles. So let's say this angle B, angle 1, it is becoming very congested. Let's say this angle B, C, and this angle B, D, and this angle B, P, and this angle B, Q. I hope the diagram is not that messy that you cannot make it out. I hope you will be able to properly understand the diagram. Okay, so now we have AD parallel to BC, and BD is a transcendental. Okay, so this will imply that we must have C is equal to angle C. This is not the vertex C, but the small, the vertex C is in capital letter and the angle C is in small letter. So C must be equal to, angle C must be equal to angle D, because they are alternating interior angles. Also, C must be equal to C and D are alternating interior angles, and again, since AB is parallel to DC and AB is parallel to DC, and BD is a transcendental, this will imply that AB is parallel to DC. This will imply P will be equal to Q. They are alternating interior angles. So let's say this be equation 3 and this be equation 4. So adding 3 and 4, we get, adding 3 and 4, we get C plus P is equal to D plus Q. Now what is C plus P? Okay, let's not use P equals to Q. We can do it Q equals to P. Q equals to P. Then we will have C plus Q. C plus Q will be equal to D plus P. D plus P. Now what is angle C plus Q? Is angle D. And what is angle D plus P? It is angle B. So we have proved that angle D is equal to angle B, and the angle D and B are opposite pair of angles. Okay, so it is proved that the opposite pair of angles are equal in a parallelogram. Okay, the third one is the diagonals bisect each other. Uh, we need to prove that the diagonals bisect each other. So let's draw the diagonals AC and DB. Let the diagonals intersect at the point O. So we need to prove that the point O is the midpoint of the two diagonals. That is, we need to prove AO is equal to CO and DO is equal to BO. Okay. Hmm. Let's consider the triangles. Okay, so we need to consider uh, let's consider the triangles in triangle AOD in triangle AOD and triangle BOC. Let's see if we can prove these two triangles to be congruent. Then we can prove that AO and CO will be equal because they will be corresponding side, and also DO will be equal to BO as they will be corresponding sides. Okay, the first of all, the very first thing we can see is that these two angles are equal as they are vertically opposite angles. So angle AOD is equal to angle BOC. BOC. They are vertically opposite angles. Okay, so one angle we found, one angle is equal. What else we can see? We know that this angle will be equal to this angle. Angle DAO is equal to angle DAO will be equal to angle OCB, as AD is parallel to BC. AD is parallel to BC and AC is a transcendental. Transcendental. Okay, so we have angle DAO is equal to angle OCB. So we have two angles equal. Two angles equal. Now, I don't two angles equal. Okay. Uh, okay. So we also have the sides AD is equal to BC, because we know that no, we cannot assume that we cannot assume to prove that the diagonals bisect each other. We just know that ABCD is a parallelogram, and from the basic properties of a parallelogram, we need to prove that the diagonals bisect each other. We cannot, even though we know that the pair of opposite sides are equal, that is AD will be equal to BC, but uh, I think we cannot assume that. Based on pure properties of parallelogram, we have to proceed. Uh, what are the congruence conditions, criteria? We have two angles equal. I don't think AAA is a congruence criteria, because even two triangles having all the angles equal may not be congruent. Okay. Mm. We need one side. We need one side. We need one common side. Hmm. Hmm. Somehow this angle is equal to this angle. Hmm. No, if we consider these two triangles AOD and BOC, without using the fact that the opposite pair of sides are equal, we cannot prove them to be congruent. We cannot prove them to be congruent. We have to consider two triangles such that they have a common side. So sorry, uh, this is possibly it won't work. Let me not delete it right away. Let me, for the time being, cross it. Okay, let's try uh, some other two triangles. Hmm. These two sides. We have to prove that AO, sorry, I'm doing, we have to prove that AO is equal to OC. AO is equal to OC. Diagonals bisect each other. And we have to prove that DO is equal to OB. Hmm. Without using the fact that the opposite pair of sides are equal, it will be, I think, a little complicated and lengthy proof. But if we know that in a parallelogram, uh, the opposite pair of sides are equal. The opposite pair of sides are equal, and that is, we know that AD is equal to BC. If we can assume this, uh, then it will be very easy to prove that triangle AOD and BOC are congruent, and from there it will be immediately we will get the result that AO will be equal to OC and DO will be equal to OB. But without using the fact that AD and BC are equal, uh, we have to consider one common side. But the diagonals bisect each other. I will, for the time being, I'm skipping this proof. Let me proceed with the other ones, and two are left. Uh, the property 5, that each diagonal divides the parallelogram into two congruent triangles, this I have already done while doing the proof of 1. While doing the proof of 1, opposite pair of sides are equal, I have already proved that the diagonal AC is dividing the parallelogram into two triangles ADC and ABC, and they are congruent. So it is already proved. For the diagonal AC, now the proof will be very similar if we consider the diagonal BD. So I will not be doing the proof of 5 because it is already done while doing the proof of property 1, that is the pair of opposite sides are equal. Let me quickly do the proof of 4. That is the sum of every pair of adjacent angles is 180 degree. So we need to prove that A and B are a pair of adjacent angles. We have to prove that this is equal to 180 degree. Also we have to prove that angle B and angle C is equal to 180 degree. We have to prove angle C and angle D is equal to 180 degree, and also we have to prove angle D and angle A is equal to 180 degree. This will be purely based on parallel lines and transcendental. Okay, so let's see. How do we prove angle A plus angle B is equal to 180 degree. Angle A and angle B. Okay, so we have BC parallel to AD. BC is parallel to AD, and AB is a transcendental. So immediately we can say that these two angles are interior angles on the same side of the transcendental AB, and we know that when in a pair of when for a transcendental intersecting two parallel lines, we know that the sum of the interior angles on the same side of the transcendental is 180 degree. So we can say that immediately angle A plus angle B is equal to 180 degree. Okay. Now how do we prove angle B plus angle C is 180 degree? So the proof will be similar. We just need to consider two other parallel lines. So we know that AB is parallel to DC, and consider BC is a transcendental. So we know, so definitely angle B, AB is parallel to DC, and BC is a transcendental. So angle B and angle C are interior angles on the same side of the transcendental BC. So we have their sum must be equal to 180 degree. So again, to prove that D and C, angle C and angle D is equal to 180 degree, we need to consider that AD is parallel to BC. AD is parallel to BC, and AD is parallel to BC, and DC is a transcendental. The side DC is a transcendental. So considering DC a transcendental and the pair of lines AD and BC, we can say that angle D and angle C are two interior angles on the same side of the transcendental. So we can say angle D plus angle C is equal to 180 degree. Again, to prove that angle D and A, their sum is equal to 180 degree, we need to see, we know that AB is parallel to DC, and AD is a transcendental. AD is a transcendental, so we can see that angle A and angle D are two interior angles on the same side of the transcendental. So their sum should be equal to 180 degree. So this proves that the sum of pair of all the sum of every pair of adjacent angles is equal to 180 degree. This is purely based on parallel lines and transcendental. Okay, so this is proved. Uh, proof 5, as I said, I already did while proving the property 1. That is, I already proved that the diagonal AC is dividing the parallelogram into two congruent triangles, ADC, triangle ADC, and triangle ABC. So, so the other proof that the triangle BD will also divide the parallelogram into two congruent triangles, the proof will be similar. I hope you can do it yourself. Okay, regarding the proof 3, I will do it at the end. Let's now solve some problems based on properties of parallelogram. Okay, the question 1 says, if two adjacent angles of a parallelogram are 5x minus 100 degree and x plus 10 degree, then the ratio of these angles is, it is talking about two adjacent angles of a parallelogram. Okay, so we know that every pair of the sum of every pair of adjacent angles of a parallelogram is equal to 180 degree. So we can say that 5x minus 100 degree plus x plus 10 degree should be equal to 180 degree. You can consider the diagram something like this. So these two angles are adjacent. It could be any other pair of adjacent angles. Just for the sake of discussion, I am considering that it is talking about these two adjacent angles, and let's say this is 5x minus 100 degree and this be x plus 10 degree. So we have their sum. Since they are adjacent angles of a parallelogram, their sum should be equal to 180 degree. So we have this. Now simplifying the LHS, we have 6x minus 90 degree is equal to 180 degree. We can ignore the degree and we can ignore the degree from both sides. We get 6x minus 90 is equal to 180. This implies 6x will be equal to 180 plus 90. This is equal to 270. So this implies x is equal to 270 by 6. 270 by 6, which is equal to 45. So x is equal to 45. Remember that x is not equal to 45 degree, but x is equal to 45 because the angles of the adjacent angle, the measure of the adjacent angles are already given as 5x minus 100 degree. So x and x plus 10 degree, over here x is not in degree but x is just a number, it will be a value. Okay, so we have x is 45 degree. So this implies the required ratio will be equal to, the first adjacent angle is 5x minus 100 and we know that x is 45. So 5 into 45 minus 100 and then divided by the other angle is x plus 10. So x is 45. So 45 plus 10. This is equal to 45 multiplied by 5 is 220 minus 100 by 55. This is equal to 320 divided by 55. After simplification, we have uh, we have 11 and 64. No, it is not matching with any of the choices. Mm, let me check if I did any calculation mistake or not. So if two adjacent angles of a parallelogram are this, then the ratio of these angles is okay. So we must have 5x minus 100 plus x plus 10 is equal to 180. I will quickly check whether I have copied the question correctly or not. Uh, Let me quickly check. 5x minus 10. Oh, sorry. It is 5x minus 10. My mistake. Sorry. This is 5x minus 10. Okay. So we have so 10. This is all wrong. Okay. So we have this. So this implies if we ignore the degrees from both sides, we have 5x minus 10 plus x minus 10 is equal to 180. Simplifying the LHS, we have 6x and 10 minus 10, we have minus 10 plus 10 is equal to 180. So this implies 6x is equal to 180. This implies x is equal to 180 by 6, which is 30. So therefore, ratio of angles will be equal to, the first adjacent angle is 5x minus it is 10. It is 10. 5x minus 10. So the first angle will be 5x. X is 30 minus 10. And the other adjacent angle is x plus 10. So x is 30 plus 10. This is equal to 150 minus 10 divided by 40. This is equal to 140 by 40. So 0 cancels out, 7 by 2. So this is equal to 7 by 2. So hence, which is equal to 7 is to 2. So the correct choice is D. D is the correct choice. So the concept applied was that the sum of any two adjacent angles of a parallelogram is always 180 degree. Okay. Problem number 2. A figure is given in the parallelogram ABCD. So ABCD is a parallelogram. The side AB is produced to P. Okay, the side AB has been produced to point P. If angle CBP is 75 degree, then angle D is equal to, we have to find angle D. Okay, so ABCD is a parallelogram. Okay, I think this is easy. We know that angle, since AB, the side AB has been produced to point P, we can say angle CBP and angle CBA are linear pair of angles. Linear pair of angles. And we know that, I hope you have already learned in your previous class that from the chapter of lines and angles that the sum of any two linear pair of angles is always equal to 180 degree. So this will imply angle CBP plus angle CBA is equal to 180 degree. Now this implies angle CBP is given to be 75 degree. And what is angle CBA? CBA is nothing but angle B is equal to 180 degree. So this implies angle B will be equal to 180 degree minus 75 degree. This is equal to 105 degree. And we also know that therefore angle D and angle B are pair of opposite angles and they must be equal. In a parallelogram, the pair of opposite angles are equal. So we can say angle D is equal to angle B is equal to 105 degree. So the answer is B. B is the answer. Sorry, not B, A. A is the answer. Okay. Let's do problem number 3. In the parallelogram ABCD, so ABCD is a parallelogram. Find the values of x, y, z respectively. So so angle C is x, angle B is z, and CB has been produced. So let's say this be point P. So the side CB is produced to point B, and the external angle is y. Okay. It is asking find the values of x, y, and z. One angle of the parallelogram is given, angle A is given. Okay, so we know that angle C will be equal to angle A since they are pair of opposite angles. In a parallelogram, both the pair of opposite angles are equal. That is, angle A will be equal to angle C and angle D will be equal to angle B. So this implies angle C has been labeled in the diagram as x. So we must have x degree should be equal to 100 degree. Since angle A is equal to 100 degree, so this implies x is equal to 100. Okay. Now x is 100. Okay. So if x is 100, okay, fine. Now we also know that angle C and angle B are pair of adjacent angles and their sum should be equal to 180 degree. Angle C and angle B in the parallelogram are pair of adjacent angles and in a parallelogram the sum of every pair of adjacent angles is equal to 180 degree. So we must have angle C plus angle B is equal to 180 degree. This implies C is x degree plus angle B is z degree is equal to 180 degree. So this implies x plus z is equal to 180. This implies x we already know is 100. So 100 plus z is 180. This implies z is equal to 180 minus 100. This is equal to 80. So x is 100 and z is 80. Okay, the choices are given as per the values of x, y, and z. So z must be 80. Z must be 80. So definitely only one choice, that is B. We have z is equal to 80. So B should be the correct choice. So x is 100, z is 80. Definitely y will also be 100. Let's check anyway. So we must also we must have z degree plus y degree should be equal to 180 degree as they are linear pair of angles. Now this implies z we have found to be 80 degree. Z is 80, so 80 degree plus y degree is equal to 180 degree. So this implies y degree is equal to 180 degree minus 80 degree, which is equal to 100 degree. So this implies y is equal to 100. So x is equal to 100, y is equal to 100 and z is equal to 80. So the correct choice is B. B is the correct choice. Okay, let's see problem number 4. Okay, in the quadrilateral ABCD, ABCD is a quadrilateral where it is given, so a diagonal AC and diagonal BD are intersecting at the point O. It is given that AO is equal to 3B minus 2, OC is given to be 2A, BO is given to be 5B minus 9 and OD is given to be 3B plus 3. What value of A would make ABCD a parallelogram? What value of A would make ABCD a parallelogram? Now we know that if ABCD is a parallelogram, then the diagonals in a parallelogram bisect each other. So ABCD is a parallelogram, parallelogram implies that AC and BD bisect each other, bisect each other. So from here we can say that AO should be equal to OC and we must have BO is equal to OD. Now AO equals to OC means AO, the value of AO, that is the length of the side AO, is given to be 3B minus 2 is equal to OC. OC is given to be 2A and we must have BO is equal to OD. So let's say this equation, we got one equation, that is 3B minus 2 is equal to 2A. Let this be equation 1. And from BO is equal to OD, we have 5B, BO is given to be 5B is equal to OD, OD is given to be 3B plus 3. Okay, so this implies, so this is a 5B minus 9 is equal to 3B plus 3. This is a linear equation in one variable, that is B. We can solve for B easily. So we have 5B minus 3B is equal to 3 plus 9, which is equal to 12. So this implies 2B is equal to 12. This implies B is equal to 12 by 2, which is equal to 6. So B is 6. Now putting the value of 6, putting the value of B as 6 in equation 1, we get or substituting B as 6, B equals to 6 in equation 1, we get 3 into 6 minus 2 is equal to 2A. This implies 18 minus 2 is equal to 2A. This implies 2A is equal to 16. This implies A is equal to 16 by 2, which is 8. So we are getting the value of A as 8. So that to make, if ABCD is to be a parallelogram, then A has to be, the value of A has to be 8. So the correct choice is D. D is the correct choice. Okay. I think this is the last problem. Okay. Problem number 5. In this parallelogram ABCD, so ABCD is a parallelogram. Angle A is given to be 70 degree, angle D is E, angle QBP. So we can see that QP and RS are straight lines. So QP is not a straight line, it is a segment, line segment that is intersecting the sides AB and BC at Q and C, Q and P. Similarly, RS is the line segment connecting, that is intersecting the sides AB and BC at R and S. So the angles are given. As you can see from the diagram, the angles are given. I hope you can see the diagram properly and the angles. It is asking what is the value of A plus B plus C plus D plus E plus F. Okay. Angle A is given. Okay, let's do step by step. So we know that Okay, so angle A and angle B are adjacent angles. And since ABCD is a parallelogram, we can say that we know that in a parallelogram, the sum of every pair of adjacent angles is equal to 180 degree. So we must have angle A plus angle B should be equal to 180 degree. Now angle A is given to be 70 degree. So 70 degree plus angle B is equal to 180 degree. This implies angle B is equal to 180 degree minus 70 degree, which is equal to 110 degree. So angle B is equal to 110 degree. Okay. Angle B is equal to 110 degree. Okay. Now also see that in using the angle sum property of a triangle, we can say in triangle S R B angle SRB plus angle RSB plus angle SBR, that is the sum of the three angles of the triangle SRB, should be equal to 180 degree. Now this implies that what is angle SRB? Angle SRB is labeled as A. So A plus what is angle RSB? RSB is labeled as angle B. And what is SRB? Angle SRB is nothing but angle B of the parallelogram ABCD. This is equal to 180 degree. Angle B, so A plus B, angle B we have found to be 110 degree. So we have this. So this implies A plus B is equal to 180 degree minus 110 degree, which is equal to 70 degree. So A plus B is equal to 70 degree. A plus B is equal to 70 degree. Also notice that in triangle PQB, using the same angle sum property, we must have C plus D plus angle B is equal to 180 degree. So this implies that C plus D is equal to 180 degree minus angle B, which is equal to 180 degree minus 110 degree, which is equal to 70 degree. So C plus D is also 70 degree and A plus B is also 70 degree. So we need now the value of E and F, or E plus F. We have found A plus B plus C plus D should be equal to 70 plus 70, that is 140. Okay, so we have A plus B equal to 70 degree. This is one result we got. We also got C plus D is equal to 70 degree. This is the second result we got. How to find E and F? E and F, where is F? Where is F? Oh, sorry, I forgot to label the F. Where is F? Oh, there is no F. Sorry, I'm extremely sorry. There is no F. There is no F. So it is A plus B plus C plus D plus E. There is no F. Okay, so we have to find the value of the sum of the angles A, B, C, D and E. So we have found A plus B and C plus D. So we just need the value of E. What is E? We have found B, so we know that angle. One second, friend. I'll be back. Someone is at the door. হ্যাঁ আসছে। Okay, sorry. Someone was at the door. So okay, so we now need the value of E. Now in the parallelogram, we can easily see that E is the angle D, and angle D, we know angle D is equal to its opposite angle, that is angle B, is equal to angle B. We have found to be angle B was what was angle B? 110 degree. So this implies E is equal to 110 degree. So now we can say that A plus B plus C plus D plus E will be equal to A plus B was 70 degree, C plus D was 70 degree, and we have E 110 degree. So this is 140 degree plus 110 degree, which is 250 degree. So the value of the sum of angle ABCDE is 250 degree. So the correct choice is C. C is the correct choice. C is the correct choice. So these problems were all based on the fundamental properties of parallelogram and a bit of parallel lines and some basic concepts of parallel lines and exterior and interior angles, and also the angle sum property of triangles. So now let me see if I can do the proof of the property 3. I failed to do this. Diagonals bisect each other. Diagonals bisect each other. Okay. We need to prove AO is equal to OC and OD is equal to OB. So to prove that AO equals to OC, definitely we have to consider two triangles where AO is the side of one triangle and OC is the side of other triangle. And similarly, that is AO and OD should be the side of two sides of one triangle, and OB and OC should be the two sides corresponding to sides of another triangle, and these two triangles should be congruent. Now I think without using the fact that the opposite pair of sides are equal, diagonals bisect each other in a parallelogram. I don't know whether this will be a proper way of proving, but I am using the fact that the opposite pair of sides are equal in a parallelogram. So if we consider, so let me use these as I started. Let this be. So we have we are considering the triangle AOD and triangle BOC. We will try to prove that these two triangles are congruent. So we have the angle AOD is equal to angle BOC because these two are vertically opposite angles. And we also have AD is equal to BC, since they are the opposite sides of the parallelogram, and we know that in the parallelogram the pair of opposite sides are equal. So AD must be equal to BC. Okay. What do we need? To establish congruency between triangle AOD and BOC, we already have one angle equal and one side equal. Now, I think vertically opposite angle will not help, will not satisfy any congruence relation. So this will not help. Okay. So we have AD is equal to BC, and we have DAO. Okay. So this angle is equal to OCB. Okay. This angle. Fine. And we also have similarly, we can say that this angle will be equal to this angle, that is angle ODA will be equal to angle OBC, because why? Because AD is parallel to BC, and BD is a transcendental. So considering the two parallel lines AD and BC and BD be their transcendental, we can see that angle ODA and angle OBC are alternating interior angles. Alternating interior angles or alternating opposite angles. I just forgot all those terms. Anyway, I hope you are getting the idea. So we can see that we have established two angles on one side equal in both the triangles. That is, we have two corresponding equal angle and one corresponding equal side. Now, in that case, we must have ASA, congruency satisfied, that is angle side angle. Now this side, the side must be included between the two angles. So we can see that AD, we know that so we have angle AD, the side AD is included between the angle ODA, between the angle ODA and DAO. ODA and DAO. The side AD is included. AD is included in triangle AOD. AD is included between angles ODA and DAO. Okay. Also, we also in triangle BOC, I'm just trying to establish the correct congruence relation between triangle AOD and BOC. So in triangle BOC, we have BC is included between angles, BC is included between angles OCB and angle OBC. Okay, so clearly we are having ASA, since we have that AD is equal to BC, angle ODA is equal to angle OBC, and angle DAO is equal to angle OCB, and we are clearly having ASA congruence relation. Now you need to properly name the congruence relation between the two triangles. So if I triangle AOD must be congruent to triangle OCB. Is it so? So AO must be equal to OC, OD must be equal to CB. No, this is wrong. This will be AOD, triangle AOD should be congruent to triangle okay, so AD is equal to BC, AD is equal to BC, and the corresponding angles are ODA. ODA is equal to OBC. ODA is equal to OBC. Okay. The AOD should be equal to AOD should be equal to COB, should be equal to COB. COB. So now you can see that if this is the congruence relation between the triangles AOD and COB, the side AO should be equal to CO, which is okay, and then the angle AOD is equal to angle COB, which is anyway equal as they are vertically opposite angles. Angle ODA should be equal to angle OBC. Angle ODA is equal to angle OBC, and angle DAO should be equal to angle BCO. So DAO is equal to BCO. Okay. So if this, from this congruence relation between the triangle AOD and COB, we can now say that AO, if you consider the first two letters of the left hand triangle, AO should be equal to CO. AO should be equal to CO, and also we can say that OD should be equal to OB. So this is what we have to prove. AO is equal to CO, that means O is the midpoint of the diagonal AC, and OD is equal to OB means O is the midpoint of the diagonal BD, and hence we can see that the point of that AB, the diagonals AC and DB has been bisected at the point O. Hence it is proved. Okay, so this brings to an end to this video where I proved all the 5 properties of parallelograms that I have discussed in the previous video, part 1, and solved few problems, 5 problems on the very basic properties of a parallelogram. I hope this video will be beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next theoretical video in this playlist will be discussing about the special type of quadrilaterals and parallelograms, that is square, rectangle, rhombus, trapezium, kite. There will be separate video for each of those special type of quadrilaterals or parallelograms. So once those are complete, I will solve the 2 exercise problems from the textbook of author R.S. Aggarwal, and after then I will parallelly start solving 5 good problems in the other playlist, that is Maths 8 Hot. So please stay tuned for all these videos coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.